let's talk about the terms isotonic, hypotonic, and hypertonic. In order to understand this topic, let's first talk about diffusion and osmosis. Diffusion is the movement of particles across a cell membrane. In simple diffusion, particles use no energy and move from an area of high concentration to an area of low concentration. Let's take a look at this cell. On one side, we see a lot of particles. On the other side, we see very few of those particles. If the particles are small enough to move across the cell membrane, the particles on the left side will move to the right side until there are equal numbers of particles on each side of the cell. Osmosis is a specific type of diffusion where water molecules move, not the other particles. The movement of water during osmosis is from the area of low solute concentration to the area of high solute concentration. In the same example, we can clearly see that there are more particles on the left side of the cell and far fewer particles on the right side of the cell. In this case, the particle may be too big to move and help equalize both sides of the cell. Here, osmosis will occur, and the water molecules will move instead. The solution on the left has a lot of particles. Think of it like sugar added to water. On the left side, you have added a lot of sugar to water. On the right side, there is less sugar added to the water. How do we even this out? To even this out, water moves from the side with fewer particles in the water, or lower solute concentration, to the side with a higher solute concentration, which in this case is on the left. Now let's look at a red blood cell. On the inside of a red blood cell, there is salt, which is important for maintaining fluid balance on the inside and outside of the cell. It is abbreviated as NaCl. Inside a red blood cell, there is 0.9% sodium chloride. If it remains at this level, the fluid balance of the red blood cell is great. Isotonic solutions are easy to understand. The prefix iso means the same. This means that the solution has the same sodium chloride concentration as the red blood cell. If the red blood cell has 0.9% sodium chloride, then an isotonic solution also has 0.9% sodium chloride. As both solutions match, the red blood cell is happy and nothing happens. In a hypotonic solution, recognize that the prefix here is hypo, which means below. This means that the red blood cell remains at 0.9% sodium chloride, but we are now placing it in a solution that is lower than 0.9% sodium chloride. So let's use one that has no sodium chloride. Now we have a mismatch of concentrations. Osmosis is now going to occur. Remember, water is going to move from low solute or particle concentration to high solute concentration. This means that there is a low solute concentration in the 0% sodium chloride surrounding solution and a high solute concentration inside the red blood cell. This will cause water to flow into the red blood cell, causing it to swell up and possibly burst. A hypertonic solution has a different prefix. Hyper means excessive or more. The red blood cell still has a 0.9% sodium chloride concentration inside it, but now we are placing it in a solution that has more than 0.9% sodium chloride. Again, there is a mismatch, so water is going to have to move to even it out. In this case, there is a lower solute concentration inside the cell and a higher solute concentration outside the cell. Water in this case still moves from low solute concentration to high solute concentration. So it will move from inside the cell to outside the cell, making the red blood cell shrink. Let's take a look at one example. A patient comes in, and the healthcare provider accidentally grabs the bag of 0% sodium chloride solution instead of the one with 0.9% solution. We are now providing the solution through an IV, and the solution is now surrounding the red blood cells. This is a hypotonic solution, which means water will start to go into the red blood cell, and at large volumes could potentially burst the cell. This is why this is an important concept to understand about the cells of your body.